Hi, I'm Dr. Incognito. In this video, we're going to find the volume of a solid using the method of cross-sections. The formula we will use is V equals the integral from A to B of A of x dx. In this formula, we have a solid which is lying over the x-axis over the interval from A to B. So A and B are the left and right endpoints of the solid. And A of x is the cross-sectional area of the solid at x. So this is the area of a cross-section at x. So in our example, let's suppose the base of a solid is the region between the two curves y equals x squared and y equals the square root of x. It's the region between y equals x squared and y equals the square root of x. So that's the base of the solid. Now, in order to figure out the volume of the solid, we will need to have an understanding of the cross-sections. So suppose the cross-sections perpendicular to the x-axis, the cross-sections of this solid perpendicular to the x-axis let's suppose that those cross-sections are equilateral triangles. Let's find the volume of the solid. So maybe first a little bit of a sketch will be helpful. Let's draw the base of the solid. Y equals x squared, the parabola opening up, and y equals the square root of x, the parabola opening sideways. These two curves will intersect at the origin and at the point 1, 1. So this region between them is the base of the solid. So the top curve here is y equals the square root of x, and the bottom curve is y equals x squared. The x-coordinate here is 1. So now if we pick any x in between 0 and 1 and draw a vertical slice in our region, then according to the fact that the cross-sections perpendicular to the x-axis are equilateral triangles, this vertical slice, which is perpendicular to the x-axis, will be the base of the equilateral triangle. So the equilateral triangle will be sticking out of the board. So for each x, we can draw a vertical slice like this, and then there is a triangle, an equilateral triangle coming out of the board. So maybe we can draw this a little bit. Maybe our base looks like that, and then we have these equilateral triangles. So our solid looks something like this. It's going to have a ridge formed by the peaks of the equilateral triangles. So the volume is going to equal the integral from 0 to 1 of A of x dx, where A of x is the area of one of the equilateral triangles. So we should discuss that. If we have an equilateral triangle with base B, and let's say it has height h, the area of a triangle in general is 1/2 the base times the height. And for an equilateral triangle, it turns out that h is equal to the square root of 3 over 2 times b. We can determine that using the Pythagorean theorem. So for the equilateral triangle, we could say that the area is equal to, if we plug the square root of 3 over 2 times b in here for h, we end up with the square root of 3 over 4 times b squared. So in our integral, this is going to be the integral from 0 to 1 of the square root of 3 over 4 times b of x squared. I'm going to emphasize here that for our triangle will depend, the size of our triangle will depend on x. As we move x between 0 and 1, our triangle starts out very small, and then it gets larger, and then it becomes very small again, because these vertical slices, as you move from left to right, they get larger to a certain point, and then they get smaller again. So the base of our triangle will depend on x. And the formula for the area of the triangle is the square root of 3 over 4 times the base squared. So the base at a given x, the base is the length of this vertical segment. The length of the vertical segment is the y value of the top curve minus the y value of the bottom curve. So b of x will be the square root of x, that's the formula for the y value of the top curve, minus x squared, that's the y value of the bottom curve. So in our integral, b of x squared is going to be the square root of x minus x squared, quantity squared. Quantity squared. So we're going to want to use the formula a minus b. Quantity squared is a squared minus 2ab plus b squared. So this is equal to, I'll take the square root of 3 over 4 out, integral 0 to 1, the square root of x squared will be x minus 2 times ab, the square root of x times x squared, and then plus b squared, that's x to the 4th. And then we integrate this term by term. To help us integrate this middle term, we should write the square root of x as x to the 1/2. So this is the square root of 3 over 4, integral from 0 to 1 of x minus 2 times x to the 1/2 times x squared. You add the exponents. 2 plus a half makes 5 halves. X to the power of 5 halves plus x to the 4th dx. And now the rest of the problem is an exercise in computing this integral. So we have the square root of 3 over 4 times the integral of x is x squared over 2 minus 2 times the integral of x to the 5 halves is x to the 7 halves over 7 halves, but instead of dividing by 7 halves, I will multiply by its reciprocal 2/7. And then plus the integral of x to the 4th is x to the 5th over 5, and we have to plug in 0 and 1. We will plug in 1, and then 0, and subtract. So when you plug in 1, you get 1/2 minus 4/7 plus 1/5. And when you plug in 0, we will get 0 minus 0 plus 0, which is 0. So that makes things very nice. So this is basically the answer. We could do a little bit of arithmetic to clean it up. It's not very pleasant. Our common denominator appears to be 70 here. It appears to be 70. So we can write these things in terms of 70ths. We have the square root of 3 over 4 times 35 70ths minus 40 70ths plus 1/5 is 14 70ths. So let's see here. 35 and 14 are 49 minus 40 are 9 70ths. So we have the square root of 3 over 4 times 9 over 70. And there's no simplifying at all. The answer is simply 9 times the square root of 3 over 280. So there is the volume of the solid. The base of the solid was a region between two curves, and the cross sections were equilateral triangles. To find the volume, we had to integrate the cross-sectional area. The left and right endpoints were at 0 and 1, and the formula for the area of an equilateral triangle with base B is area equals square root of 3 over 4 times b squared. There are simpler figures to deal with in equilateral triangles, but this is what you have for an equilateral triangle. So here we are integrating the square root of 3 over 4 times the base squared, and for emphasis here, we included x. B depends on x, and the formula for the base was the top curve minus the bottom curve. So square root of 3 over 4 times the base squared, and then some algebra, and then the integral, and then some arithmetic. Okay, so there's the volume of the solid using the method of cross sections. Thank you for watching this video. I hope you found it helpful.